close, close. Okay, today we're going to talk about solving logarithmic equations. We're going to start by going back to page 3 to look at the steps for solving. So if you were absent on the day that we wrote these steps, you might want to go back to page 3, or if you just forgot, we're going to go back to page 3. So solving just has a couple basic steps. One, you have to look at both sides of the equation and make sure you condense each side. So if you have more than one logarithm on one or both sides, you have to condense those using the power, product, or quotient property, or a combination. And the second step is look at the form of the equation that you're working with. Sorry, that says form. Form A, we'll call form A the form that looks like this. Log base b of n equals p. So it's in log form. You need to convert to exponential form, which is b to the p equals n. And if you have the form b, you need to, which looks like this, log base b of some argument x is equal to a log base b of some argument y. So you have a log on both sides, basically, is what I call that. You'll just drop the logs. Drop the logs. And then make sure you check to make you solve for x, solve for the variable. And then last, and very important in these problems, is to check, because your argument has to be positive. Okay, so we did some already where we had to solve this kind, where we convert. We have not solved this kind, but they're not very difficult. So the trick when you get a log equation is to figure out which it is to condense, which we just learned how to do over the last couple days, and then look at your form. Solve, check to make sure the argument is positive. So we're going to try some problems. Let's move this. We're going to divide our paper into 3 sections, one big one on the bottom, and divide the top half into 2 parts. So the first problem we're going to solve is log base 2 of 5 plus log base 2 of x equals log base 2 of 15. I want you to solve that. So you've got to first condense. First step is condense. This sign right here tells us it's the product property we're going to use. So we would multiply the 2 arguments, 5 and x. So we have log base 2 of 5x equals log base 2 of 15. When I have a log on both sides, I just drop the log and I end up with 5x equals 15. That just tells me divide by 5 and x equals 3. Check to see if that makes your argument positive, and it does, so that's a solution. So a simple case, sometimes you get them like this, but you could get where you have just you have more than just an x, you have an expression for your argument. So let's look at one like that. Log of x minus 3 plus log of x equals 1. I still am using the product property, so I multiply x times x minus 3, which gives me log of x squared minus 3x. Don't forget to distribute to both terms in this binomial. And that's equal to 1. Well, I don't have a log on this side, so that tells me I'm going to convert to exponential form. So I need a b, a p, and an n. And my b, since there's no base showing, is 10. P is the number on the right, and n is this expression in your argument. So I write 10 to the 1. I don't have to write the 1. 10 to the 1 is just 10. Equals x squared minus 3x. Now, this isn't a linear, this is a quadratic because it's a power of 2, degree of 2. So I have to get a 0 on one side. So that means I have to subtract the 10. And I have 0 equals x squared minus 3x minus 10. I'm going to run out of room here, so I'm going to erase a part of this line here. And I'm going to use the big X because I think I can factor that. If I can't factor it, I have to use a quadratic formula. Factors of negative 10 that add up to negative 3, 5, and 2. And since this is negative, the 5 is my negative. And I just take for my solutions the opposite, so 5 and negative 2. And if I plug these in, 5 is fine because that makes 2 there and positive 5 there. But negative 2 is not going to work because that makes that negative 5 and that negative 2. So my only solution for this one is 5. There's your second example. Third example is going to use the same thing. You're going to end up with a quadratic, but you can't factor it. So we're going to look at how to solve using the quadratic formula, which you've already learned, but we're going to review it basically. So I have log base 2 of x plus 1 plus log base 2 of x equals log base 2 of 3. Combine these because it's the product property. You have log base 2 of x times x, which is x squared, and x times 1 is x. And this form is form B because I have log equals log, so I can get rid of those and I can just set my arguments equal. X squared plus x equals 3. And it's a quadratic again, so I have to subtract 3 to get a 0 on that side. So I have 0, and I have x squared plus x minus 3 equals 0. And this can't factor because there's no factors in negative 3 that add up to 1, so I have to use the quadratic formula. So x equals negative b plus or minus b squared minus 4ac all over 2a. And I plug in the numbers for a, b, and c. b is 1, a is 1, c is negative 3, and a is 1. And then evaluate. So I have negative 1, and then 1 squared minus 4 times 1 times negative 3. Negative 4 times negative 3 is positive 12, so this ends up being square root of 13. And then 2 times 1 is 2. If I put those in my calculator, negative 1 plus square root of 13 over 2 gives me 1.3, and negative 1 minus square root of 13 over 2 gives me negative 2.3. But negative 2.3 isn't valid because I can't plug it in here and get a positive. So I'm only going to use that 1.3 for my solution. That's page 3, or I'm sorry, that's page 6. You can stop and go back over those. If you need to pause the tape, that's fine. I'm going to move on to page 8. Page 8 is just going to have one big example. And that example is log base 5 of x minus 2 minus log base 5 of 2x plus 1 equals log base 5 of 4. Okay, it just takes up a lot of room. It's not any harder than the other ones. We're just using the quotient property instead of the product property. So I take this argument divided by the second argument, and I have log base 5 of x minus 2 over 2x plus 1 equals log base 5 of 4. And I have my form B because I have log equals log, so I can drop the logs and just write x minus 2 over 2x plus 1 equals 4. And I can use cross multiplication to solve this. If I put a 1 down here, x minus 2 times 1 is just x minus 2 equals 4 times 2x plus 1. Don't forget to multiply the 4 by both terms in this binomial. So 4 times 2x is 8x, and 4 times 1 is 4. And then I can just solve for x. I have negative 2 equals 7x plus 4, and then negative 6 is equal to 7x. Divide by 7, and I get x equals negative 6 over 7. Remember to check that solution And it's not going to work because the negative 6/7, whatever it is, minus 2 is still going to be a negative answer. So this is not a valid solution. So I just write no solution. Okay, so that happens quite often in these kind of problems, depending on what you get for your answers. You might have two solutions and only one of them works. You just have to make sure you're checking. And page 10 of your booklet just has one problem also. 2 log base 3 of x equals 4. And this one I want to use because there's a coefficient here. Remember, if there's a coefficient here, it becomes the power of your argument. So I have log base 3 of x squared equals 4. This is form A because I don't have a log on this side, so I need my b, p, and n. My b is 3, p is 4, and n is this whole argument, so it's x squared. So b to the p equals n. 3 to the 4th power equals x squared. 3 to the 4th power is 81, so I have x squared equals 81. I'm just flipping it around. You can do that. And then take the square root, and you get x equals plus or minus 9, because remember, for a quadratic you have two solutions, a positive or a negative. And I don't want to use the negative because that makes this negative. So the only solution is positive 9.